Ever notice how we don't even think about a cut healing up?
Yeah,
It's kind of like magic.
it really is.
But on this deep dive, we're going deep into the science behind all that. The fascinating world of platelets. You sent us a really cool article, actually, from Genie.
Okay.
Understanding platelet activation, a comprehensive overview. So clearly you want to know more about these tiny cells.
Yeah.
So let's get into it.
Platelets. Tiny but mighty. Absolutely essential for blood clotting.
Okay, so this article, it jumps right in with this striking image. Platelet activation overview, it shows these little round cells transforming into these crazy starburst shapes.
Oh, wow.
Almost like watching a microscopic fireworks show.
Oh, cool.
So what's the deal with this dramatic makeover?
Well, it's their secret weapon, that shape-shifting. Think of it like this.
Yeah.
In their resting state, platelets are like these tiny little smooth discs just cruising along in the bloodstream. But when they get the signal that there's been a breach in a blood vessel, bam, they undergo this incredible transformation, sprouting these arm-like projections called filopodia.
Filopodia?
Yeah.
Is there a way to explain that so it doesn't sound like something out of a sci-fi movie?
Imagine Spider-Man shooting out his webs to swing from building to building.
Okay.
Filopodia are kind of like that. They allow platelets to latch onto that damaged site and start forming a plug.
Ah, so it's not just a visual change. It's like the first step in this whole chain reaction of stopping the bleeding.
Exactly. And that increase in surface area from all those filopodia, that's crucial for the next steps. Adhesion and aggregation. Adhesion is where the platelets really grab onto the exposed collagen at the injury site, anchoring themselves like a team of microscopic rock climbers. And then aggregation comes in. That's where they start calling in for backup, clumping together to form that initial plug.
Okay, that makes sense. So how do they actually send out that we need backup signal?
That's where the release reaction comes in. The article talks about these little packages called granules inside platelets. Imagine them as tiny little emergency kits packed with all sorts of potent signaling molecules. Things like ADP, serotonin, and thromboxane A2.
Oh, okay.
These molecules, they're basically like chemical flares shouting, "Emergency, we need all hands on deck."
So it's like they're calling for reinforcements, like a microscopic 911 call.
Exactly.
Oh.
And each of those signaling molecules has a slightly different job to do. ADP, that directly activates nearby platelets, getting them to join the party and stick to the growing plug. Serotonin helps constrict the blood vessel, sort of like tightening a belt to reduce blood flow to the injury. And thromboxane A2, that's like the amplifier, making sure the message is loud and clear for all the platelets in the area.
Wow, it's amazing how this all happens so quickly. You'd never know this whole drama was playing out every time you got a paper cut.
It's a remarkable process, incredibly fast and efficient. But what's even more interesting is that this is just the tip of the iceberg when it comes to platelet function.
Wait, there's more. I thought their main job was just to form clots.
Oh, they do so much more than that. And that's actually what caught my eye about the references listed in this article. There are 7 of them. That tells me there's a lot more to uncover about these fascinating cells.
I'm looking at some of these titles now. Platelets in atherothrombosis, platelet functions beyond hemostasis. It sounds like platelets are involved in a lot more than just stopping bleeding.
You're absolutely right. They played a role in inflammation, immune responses, even wound healing.
Wow.
And all of these functions can be interconnected in really complex ways. It's like platelets are the ultimate multitaskers of the body.
Okay, now I'm really intrigued. So we've got this picture of platelets as these tiny little first responders rushing to the scene and plugging up leaks. But it sounds like they have a whole other side to them, more like a construction crew helping to rebuild and repair.
That's a great analogy.
Right.
That's exactly what we're going to explore in more detail in the next part of our deep dive.
Okay, so we've established that platelets are like the superheroes of our bloodstream.
Yeah.
Patching up wounds faster than we can say ouch. But you're telling me there's even more to these tiny powerhouses.
All
Okay,
right.
I'm ready.
Well, imagine a construction crew that not only repairs the damage, but also directs traffic,
Okay.
coordinates with the architects,
Mm-hmm.
and even helps with landscaping.
Wow.
That's kind of what platelets do.
Okay, that's a pretty impressive skill set for something so small.
Yeah.
Break it down for me. What are some of these other roles that they play?
Let's start with inflammation. You know how when you get a cut, the area around it gets red and swollen?
Mm-hmm.
That's inflammation at work. Crucial part of the healing process.
Yeah.
And guess who's right there in the thick of it? Platelets.
Of course.
They release signaling molecules that attract immune cells to the site of injury, like calling in reinforcements to fight off any potential infections.
So they're not just plugging the hole, they're also making sure that the area is protected from invaders.
Yeah,
Clever.
exactly. And it goes even further than that.
Hmm.
Platelets also play a role in wound healing itself.
Really?
Yeah. They release growth factors that stimulate the formation of new blood vessels and help rebuild damaged tissue. It's like they're laying the foundation for a brand new structure.
Wow. They really are the ultimate multitaskers.
Hmm.
But hold on. If they're so good at activating and getting things done, how does the body make sure they don't go overboard?
That's a great question. And it's where things get really intricate.
Mhm.
Remember how we talked about the clotting cascade?
Yeah.
That chain reaction of events that leads to a stable clot? Well, it's not a one-way street. There are mechanisms in place to make sure that the process stops once the job is done.
So it's like having a built-in off switch. But how does that work exactly?
Think of it like a delicate dance between activating and inhibiting factors.
Hmm.
There are molecules that promote clotting and others that counteract it. It's all about finding the right balance, like a thermostat that keeps the temperature just right.
Okay, so there's like a whole system of checks and balances to make sure things don't go haywire. But what happens when that system malfunctions?
That's where we get into the territory of bleeding and clotting disorders. Too much clotting can lead to thrombosis, which we've already discussed. But on the flip side, if the clotting process is impaired, even minor injuries can result in excessive bleeding.
So it's like a bit of a tightrope walk. You need just the right amount of platelet activity to stay healthy. What are some of the things that can throw off this delicate balance?
Well, there are a number of factors that can come into play. Genetics can predispose some people to bleeding or clotting disorders. Certain medications can interfere with platelet function. And even lifestyle factors, like smoking and obesity, can increase the risk of complications. It's a complex interplay of variables.
Sounds like there's a lot we still don't fully understand about platelets and how they interact with the rest of the body.
Absolutely. And that's what makes this field so exciting. There's so much more to discover about these amazing cells and their potential for both good and ill.
Okay, so we've covered a lot of ground here. Platelets are not just these simple clot-forming machines. They're involved in this intricate web of processes that keep our bodies functioning properly. What else can we glean from this deep dive into the Assay Genie article?
Well, one thing that really struck me was the article's mention of pathological implications. It's a reminder that when things go wrong with platelet function, the consequences can be serious.
Right, we touched upon thrombosis earlier, but what about the other side of the coin, the bleeding disorders? I'd love to hear more about those.
That's a great place to pick up in the next part of our deep dive. We'll explore some of the different types of bleeding disorders, what causes them, and how they can be managed.
Okay, listener. We've spent the last 2 parts of this deep dive exploring this amazing world of platelets, how they spring into action to stop bleeding, their role in inflammation and wound healing, and that delicate balancing act that keeps them in check. But as we've hinted, things can go wrong with this system.
Absolutely.
Right.
We've talked about the dangers of excessive clotting, thrombosis. But now let's flip the script and delve into the world of bleeding disorders. These are conditions where, for various reasons, the clotting process is impaired, making it difficult to stop bleeding, even for minor injuries.
So it's like the brakes are faulty,
Mm-hmm.
and even a little nick can turn into a big problem.
That's a great analogy. And just like there are different types of brake failures, there are different types of bleeding disorders. Some are inherited, meaning you're born with them due to genetic factors. Others are acquired, developing later in life due to other health conditions or medications.
Okay, so let's talk about some specific examples. The article briefly mentions von Willebrand disease. What's going on there?
Well, remember how we talked about platelets needing to grab onto the damaged blood vessel wall?
Yeah, like microscopic rock climbers.
Exactly.
Yeah.
Von Willebrand factor is a key protein that helps them do just that. But in von Willebrand disease, there's either not enough of this protein or it's not functioning properly. So the platelets can't adhere effectively and the whole clotting process is slowed down.
So it's like they're trying to climb a slippery slope without any ropes.
Yeah,
No wonder it's hard to get a grip.
exactly. And it's actually the most common inherited bleeding disorder, affecting about 1% of the population.
Wow, that's a lot more common than I thought. So what are the symptoms? How does it actually affect people's lives?
It can vary quite a bit depending on the severity of the deficiency. Some people might just experience easy bruising or prolonged bleeding after minor cuts or dental procedures. Others might have more serious issues, like frequent nosebleeds, heavy menstrual bleeding, or even bleeding into joints or internal organs.
That sounds really challenging to live with.
Yeah.
What about other bleeding disorders? The article also mentioned hemophilia.
Right. Hemophilia is another well-known inherited bleeding disorder, but it's a bit different from von Willebrand disease. Remember that chain reaction of events, the clotting cascade we
Yeah.
talked about? Well, in hemophilia, it's not the platelets themselves that are the problem, but rather specific clotting factors, proteins that are essential for the cascade to work properly.
So it's like one of the links in the chain is broken, then the whole thing falls apart.
Exactly. There are different types of hemophilia depending on which clotting factor is deficient. The most common are hemophilia A, which is a deficiency in factor VIII, and hemophilia B, which is a deficiency in factor IX.
And what are the implications of these deficiencies?
Well, without those crucial clotting factors, the final step of the clotting cascade, the formation of a stable fibrin clot, is disrupted. This can lead to prolonged bleeding, both internally and externally.
So even a small bump or bruise could turn into a serious issue.
Right.
It must be incredibly difficult to live with the constant worry of bleeding episodes.
It certainly can be. That's why early diagnosis and proper management are so important for people with bleeding disorders. There are treatments available, like replacement therapy for missing clotting factors, that can significantly improve quality of life and reduce the risk of complications.
It's amazing how far medical science has come in understanding and managing these conditions. It makes you appreciate just how complex and delicate this whole system of blood clotting really is.
It really is a testament to the intricate workings of the human body. And the more we learn about platelets and their multifaceted roles, the more we realize how crucial they are for our health and well-being.
Well, I think we've given our listener a lot to ponder today. We've gone from taking blood clotting for granted to understanding this amazing world of platelets, their role in various bodily processes, and the implications when things go wrong. Who knew these tiny cells could be so fascinating?
Yeah, it's a journey of discovery. It highlights the importance of staying curious and informed about our own health.
Exactly. And to our listener, we encourage you to continue exploring this topic. Dive deeper into those references from the Assay Genie article, seek out other resources, and keep asking questions. As we've seen today, there's always more to learn, even about the seemingly simple things we take for granted. And as always, if you come across any other fascinating articles or research that sparks your curiosity, send them our way. We're always up for another deep dive.